Good morning once again to each and everyone. So for today, we're going to discuss about the implementing the model-driven architecture. And of course, uh, in this lesson, no, we will be able to describe in detail the concept and terminology of the MDA and the rule of transformation and refactoring. No, we could able to show how transmission can formally represented and justified, and we can conclude with a survey of current MDA technology. So again, uh, there are some key concepts no covered with the MDA. No, number one is the CIM, or the computation independent model, wherein a CIM is an abstract completely from implementation details and uses terminology familiar to practitioners in the domain of the application. It is similar to the concept of a domain model. So and it can use to assist in establishing requirements and expressing this in detail. So it describes the systems in terms of the domain in which it must operate. Okay, so last time we discussed about UML, or the UML notation such as class diagrams and state charts can be used to define CIMS. No, so only declarative constraints should be used to specify functional behavior. And I think the presenter will be able to discuss about the model transmission, the MDA, and PIM at the same time. Okay, to give us more details about the topic, let us all welcome Sir Isaiah. Go ahead po.
Thank you, sir. So, yeah, thank you for introducing the topic, sir. I'm Isaiah, and I'll be going to present implementing the model-driven architecture. But before I go through my slides, I would like to give you some. I would like to refresh you regarding model-driven architecture. So, the model-driven architecture defines as an approach where the specification of the functionality of a system can be separated from its implementation on a particular technology platform. So the idea is the architecture will be able to easily be adapted for different situations, whether they are legacy systems or a different language or an invented platform. So yeah, that's the NDA is therefore a significant evolution of the objects-oriented approach to the system development. So yeah, so much of the topics that I'm going to explain here is focuses on how to implement this architecture, and some terminologies and some approaches that you need to remember in implementing MDA, or different approaches and different tools. Yes, so yeah, let's go to my slides. So before we go through the different approach, I'll give you some basic terminologies about MDA. So we have the computation independent model. So I think Sir has already mentioned this, but I will just repeat. So it abstracts completely from implementation details and uses terminology familiar to protect practitioners in the domain of the applications. So computation independent model, just to add, is this is being made by business analysts to describe the business and business rules. So, and second terminology is model. So model in the context of MDA is it is a representation of a part of a function, structure, or behavior of a system. Model transformation. So it is a conversion of one model from a system to another model of the same system. So one great example of this is the PIM to PSM transformation. So I'll be telling about that more later. Yeah, I actually had this sample of um, model transformation strategies for PIM to PSM. So as you can see, there are two approaches here that was mentioned. We have the marking strategy, where we need to add a mark which can be a stereotype, such as persistent or some other identification of a particular intended implementation of a PIM model element. And the second approach is the meta model mapping. So I'll be explaining that during the course of the the topic. More MDA terminologies. So we have pervasive services. These are services provided by the platforms which are shared between all applications on that platform. Yeah, now we go to the platform. So it's a sets of technologies and functionalities which are available to any application based on that platform. So for example, it's J2EE or Java environment for Java. And this one is kind of important for this topic, which is the platform independent model. So platform independent model captures all essential information about the properties of the system, independent of particular implementations. So, okay. So project independent model includes the entities involved or with their attributes and operations, the relationships between entities with multiplicities, life cycle of objects such as state charts, logic static properties expressed as constraints on classes and associations, and logical behavioral properties expressed as pre and post condition constraints on operations. So basically, PIM, it's the architecture. This model is designed by architects or designers to describe the architecture of the system, which can be transformed into PSM. Yeah, that will I will tell or explain further. So this is a version of so for PSM or platform specific model. So it is a version of a PIM tailored to a particular implementation environment. So I think one example here is there are many architectures that was created, but sometimes we have to implement it on different platforms. Like when if you're using middleware program such as Java, you have to implement it there. But if you if you want to implement it in a business application, like the technology that I'm using is Salesforce. So I think this terminology fits that scenario. Even though that there are many implementations or there are many platforms that being used to develop or build systems, the architecture will be the same if it's PIM. But for PSM, it should be catered to the specific platform only. So another example is PIM may derive from a class equate form in the PSM, which describes an input form on a web page for creating instances of an E for an online version of the system. So for PSM, the PSM doesn't add any new logical properties, but it may add computation and algorithm detail and transform the PIM elements to conform to the fiction of the platform. So yeah, different platforms has its own limitations. For example, in Salesforce, the platform that I'm using, we have governor limits. So if we're going to implement PIM if we're going to implement PSM that was derived from PIM to our Salesforce platform, we have to conform it with the governor limits of Salesforce. So this okay. Next, refactoring. This one terminology here, parameterize behavior preserving program transformation that updates an application design and underlying source code. So it basically it just updating the codes, the existing codes to make it efficient, more efficient. Yeah. Reverse engineering. So reverse engineering, it is a process of extracting a design or specification from an implementation of a system. Okay, so this actually necessary if an org wishes to capture business rules which may be embedded in the legacy app. So next, two more terminologies. We have round-trip engineering. So this reverse engineering followed by normal forward engineering, PIM to PSM transformation. This is used to port an application from one platform to another. And lastly is virtual machine. It is a catalog of operations and services which are independent of any particular platform, but can be implemented in several platforms. So defining a platform independent model in terms of virtual machines means that the work required to implement the PIM can be reduced since the virtual machine may already have an implementation on the target platform. So these are the terminologies that you have to understand before we go on to the next topic. So one way to implement model MDA or model driven architecture is model transformation. So this is fundamental actually to the MD8 approach. So either it is a means to improve a model to make it more generic and flexible for use as a PIM, or means to transform PIMs to PSMs. So PIM, whenever we build PIM, I think as much as possible, this should be very generic. Like in maybe in an organization, if you like to implement an architecture such as PIM to different platforms, you have to make sure that all of the components there are generic, and it can be used and it can be flexible to all of the platforms that you're going to implement this PIM. So for reverse engineering and round trip engineering, PSM to PIM transformation, essentially ways of abstracting away from model specific details are also important. Yeah. Okay. Yeah. So some concepts about model transformation. So let's start basically on the basic basic concept of transformation, which is model. So without model, we have nothing to transform, right? So for model, for this context, this is a collection of UML model elements. It can be regarded as an instance of UML metaclass subsystem linked to objects representing the object elements of that particular model. So as you can see here, there are two images here. So as you can see, the first image here is an example of a model. So this model has three classes, A, B, and C, and we attribute. So A and B had this attribute P, and there are two associations. So A is associated to C, B is associated to C. So I can say that this is many to many. So yeah, and this model is actually a meta. Sorry, it's a subsystem or a part of the larger diagram here on the below as a meta object. So as you can see here, this is the M1 model M1 here on this part, and the model M1 here is the details of that. It's on the first picture, and there are different instances here for that subsystem. So we have the A class, the B class, and association AC, and the attributes as well. So yeah, that's how the model works. Another image here is the UML 2.0 meta model. So it's basically a more detailed explanation of how models work in context of UML 2.0. So this is the metadata for UML 2.0. So if you're familiar with UML on the previous session, you might be familiar with this. So as you can see here, a model element has partly defined by the values of its meta features. So there's a lot of meta features here. Um, a model element also has semantics, which defines what its value can be at any point. So for example, this class element here, there are some semantics here like property and operation. Anything else? Yeah, to be honest, this is very this model is pretty complicated to explain, but yeah, from what I understand is basically this element has this different meta features here. So we have the type element relationships, class, type, and this, yeah. So as you can see here, you can see here how are they related to each other. Next, so this is how we're going to transform a model. So transformation between models can be expressed as relationship between corresponding elements. So for if you remember A, B, and C on the model one, so they have both an attribute called attribute T. So to transform that model, one approach is to introduce a superclass. So as you can see here on the picture here, this is now a superclass. Since A and B has the same attributes, we have created a superclass where where the attributes for A and B are mapped to that superclass, and that superclass will not call the attribute. And by that, this superclass can only be relate to C. So it means that there's only one relationship anymore. There's only one relationship already aside from two, because we have kind of combined class A and class B into a superclass and relate it to the C class, which is the previously related classes for A and B. So yeah, that's one way to transform it, introducing superclass. Where am I? Okay. Yeah, so there are different categories in transforming models. So we have quality improvements of models category, we have the refinements, and we have the abstractions. So for quality improvements of models, we have introducing a superclass, marking partial rows into total. On refinement section, we have introducing design patterns, transforming platform-independent model types into platform-specific model types, removing multiple inheritance, removing many-to-many associations, introducing primary and foreign keys, source or target splitting on state charts, and amalgamating subclasses. And for the abstractions category, we have replacing PSM types by PIM types. So I'm going, there's more explanations on this approaches. So as you may know, I already explained how to introduce a superclass. So maybe let's go to the other approaches. Yes, so I'll wait for a sec. Okay. I have to get my water. Okay. Okay, so yeah, I actually going back to the first approach, which is introducing a superclass. So this is used to simplify a class diagram and remove duplicate features from it. So as you have seen on the previous example that I have, the duplicate features for class A and B is the attribute. They have both attributes, right? So if you notice that your elements have the same attributes, one way of transforming that is to introduce superclass, combine it together, or group the same attributes on one superclass and just call it on your subclass. Yeah. So yeah, it's already said here. So this is simple to apply if two classes have a common subset of attributes and operations. So as you can see here, there's this sample. Okay. That's one example. Yeah. So this is a sample of an avalanche dispatch system. And what is noticeable here is there are some associations, several associations with the same meaning. So we have the ambulance hospital and ambulance incident. So it seems that these two are kind of located um, at the same location. So if you have, yeah, so since they're pretty related to each other, and one way to see that the relation is by another association, which is patient. So patient might be getting ambulance from an incident, or patient might be having the ambulance in the hospital. So since they have that same kind of relationship or features, what we have to combine these two, incident and hospital, into one superclass called location. So on the location, we can classify if that location is an incident or the location is an hospital. And that superclass is the one that we can relate to the patient and to the other objects that we need to relate to. So that's one way to introduce that. Okay. Next approach, making partial rows total. So yeah, this another approach on yeah, another approach to transform models. So as you can see here, there's this. Hello. Okay. Can you still hear me, guys? Hello.
Yes, sir. Go ahead. Yes, Opo.
Yeah. Okay. Good. Sorry. There's some changes on my audio. Okay. But anyway. Okay. So another approach is making partial rows total. So as you can see here, there are three classes again. It's just A, B, and C. So if you can visualize this, let's say A is a bank account, B is the person, and C is the company. So if you have a bank account and you might have different roles, instead of having two classes that define those roles, why not combine it in a single superclass where we can classify that role on that class based on if it's a person or a company. So this kind of the same approach with superclass, gaining superclass, but this one is like having combined roles for a specific entity. Yeah, and yeah, um, I think this formula can explain it more, but yeah, the formula is pretty bit complicated. So I hope you understand what I mean here. But so just to simplify that, if if you have several roles for a specific entity, you might combine it in a superclass and try to differentiate the role on that superclass to your entity. Next approach is the removal of many to many associations. This replaces many to many with a new class and too many to one associations. So as you can see here, there's this A and B class again with many to many relationships. So sometimes many to many relationship, it's pretty it's not sustainable in the long run. So one way to transform that is to have another class, and that class will be the relationship between A to B. So you on C, okay, so you have the class here called C class, and that C class will contain by maybe the primary key of A and the primary key of B. So in that way, A and B can still be related to each other by the C class. So maybe I encounter this at work. So in Salesforce, we have this whenever we are planning to create many-to-many objects, we are actually one way to implement that is to create an object called junction objects. So junction object is like an object which includes records from two different objects. So maybe I could give some example of that. So okay, so maybe one object that I can explain is uh class A might be the opportunity or the sales details, and B is the contact details. So yeah, contact details. So we have another option. We have another junction object on that called opportunity contacts, where we list all of the different contacts on that opportunity that is part of the stakeholders of the opportunity. And we have the opportunity ID on class C or on that object, and we have the contact ID on that object too. So is the that is the composition of that object, and we are using that junction object to relate that object to many sub objects in Salesforce. So that's one way that I can explain that. Yeah, I actually encountered this approach. Next next approach is replace inheritance by association. So this useful to remove situations of multiple inheritance from PIMs. So as you can see here, there's this class A and B. So it seems here that class B is like a it's like a child of class A. Um, Maybe that's not a right way to do it. So one way to transform it is to, instead of having an inheritance, we can have a relationship for that. So as you can see here, it was transformed. So we have A here, A object and B object with a relationship. So it seems this is to um, one to one, you think. And the one to one here, the one here is free and not required. So yeah, that's one way to do it. Another approach is replacing associations by foreign keys. So this is applicable to any explicit many-to-one association between persistent classes. It assumes that primary keys already exist for the classes linked by the association. So as you can see here on the image, so we have another class A and class B with the relationship one to many. And we have, in class A, we have the A key or the ID probably, and the B key on the B class. So if you want to transform it using this approach, one way to do it is to have the foreign key on a specific object. So on this case, we can put the foreign key on B class, which is the A key. So in that way, we can relate A and B with the foreign key. So in Salesforce, this is actually one approach that we are doing in Salesforce. If you want to relate an object to each other, we're creating this field, lookup field, and that lookup field will be populated by another object record which has an ID, and that ID will serve as the foreign key for that lookup or that object. So yeah, I encountered this too. Yeah, so that's some of the approaches that that was detailed in the book. Now we can go to UML profiles. So UML profile UML the UML model can be extended with profiles. which allow the definition of platform-specific constructs, such as entity, Java Bean, compound key, or phone. So what is a URL profile anyway? So URL profile consists of a set of stereotypes which are defined in the profile by their name and set of URL meta classes that they apply to. So basically, this is kind of like a definition in my understanding uh, of a specific meta class, and that can define how that meta class works, or yeah, what are the features of that meta class. So this one example of UML profile for web applications. So as you can see here, a solid headed arrow from the stereotype to the meta class indicates that a particular instances of a meta class can be a stereotype or marked by the stereotype. So as you can see here, both class and association meta class has this stereotype core persistent. So this means that class and association can be marked as persistent. So profiles can be used to define PIM or platform specific model to platform implementation model or PIM to platform specific model mapping. So with the profile stereotype attached to the model elements, determining how the elements are transformed. So this stereotyping here, this can be used to transform PIM to PSM and by mapping these stereotypes to them. Okay. Okay. So transformations for internet system. So I guess this is the part that we are trying to apply the terminologies and the concepts that I discussed earlier to a specific scenario, which is for internet systems. So I think someone of you have explained internet online implementation of an information system. So that topic is actually a concept of transformation using PIM using the MDA approaches. So this transformation adopts the marketing strategy using a profile whereby elements of the PIM are given a marking to indicate what elements should be used to implement them. So what are the markings used, by the way, on transform or implementing the internet systems? So we have persistent on classes, implicit and explicit on associations, and create, delete, add, remove, list, check, and get and edit on operations. So what are the based on the approaches or the strategies that I explained earlier, I actually map it on what approaches this online implementation of data systems has. So for that scenario, the transformation approaches that we've done is removing multiple inheritance, removing many-to-many associations, introducing primary and foreign keys. Yeah, and basically these are the approaches that was done on that implementation. Okay. Okay, going back there. So, okay. So yeah, that's actually one example of it. So now we are going to different alternative approaches on implementing model transformations. So because of the importance of model transformations to the MDA process, techniques specifying and implementing such transformations need to be considered. So there are actually three kinds of approaches. alternative approaches in implementing transformations. We have XLSD, or extensive style sheet language transformations. We also have rational rows, or RAI. It's an inbuilt support for rational rows for UML in transformations. And third is Java. So Java has this metadata interface that we can use to manipulate the metadata and implement MDA approaches. So I'm going to explain this one by one. Okay, where am I? Sorry. So XLSD. So XLSD stands for extensive. Sorry. Okay, let's go back there. Extensive style sheet language transformations. So it is an XML notation which can be used to transform one XML document to another. It is typically used to mark up an XML document into an XML doc, XHTML doc form when rendering in a browser. But it can be also used for data transformations from XML docs that represent UML diagrams from a PIL into XML for corresponding PSM diagrams. So since XLSD is used to transform one XML file and another, this is a good way on transforming PIM models into PSM models by using XML docs. So there, as you can see here, I defined some advantages and disadvantages of this approach. So the advantages of this approach is it is very low cost. So you just need to have an text editor. You can create your XML if you're familiar with it. XML is also become the standard language for data interchange between tools. So this pretty useful, and yeah, it can be used anywhere, especially on this example. But there are some disadvantages though. So it's very verbose. So it means that it requires all details of the output to be specified. And since this XML, so you don't have like a visibility on the model. So you have to like code it, or you have to use your imagination probably whenever you code it. So that's very hard if you are doing this approach. There are difficulties in separating the source and target parts of rules and filtering constraints. And debugging is very, very difficult. So these are the disadvantages. Another approach is the RAI. So RAI, it's a tool provided by the rational rows case tool. This enables developers to create software which extends and customize the rows tool for particular purposes. One purpose is to transform the models. So the RI is based on a model of the really rational rows models, which is very similar to the UML meta model. So the advantages of using RI is RI scripts are clearer to read and easier to maintain, and the developer is dealing directly with models rather than text representing it. Just like the first approach, which is the XLSD. But disadvantages for this is greater expertise in programming is needed, since this is a very intricate tool, I guess, and this is paint. I'm not really sure if this is if this approach or this tool is still active, but I'm gonna check. Maybe I can check. Rational rows. I think it's still active, I guess. Yeah, I guess it's still active. Yeah. Okay. So next. And lastly is the Java approach. So Java method interface, or JMI, provides Java interfaces to access and manipulate meta models, include DML 2.0 meta model. So yeah, I think that's straightforward. Java has this tool to transform UML 2.0 metabolic models. So the advantages of that is the developers still dealing directly with models rather than text. But the disadvantage for that is please disregard this paid tool. It's not paid. But you have to have great expertise in programming, especially in Java. Yeah. So the approach actually is like this. So a UML model to be transformed is stored in XML format and used to populate the meta model repository for UML. GMI methods are then used to query and update the repo in order to implement the transformation. So that's how it works. Okay, so that's the 3 alternative approaches. And here are some tools that you can use in your MD implementation. So we have OptimalJ, CodaGen Architect, and Sauce Inc. I tried to research for this. It seems that OptimalJ is already obsolete. CodaGen, I don't think it's very active. It seems that the website's very old. Sauce Inc. I also have I didn't see anything about this as well. But yeah, just for the purpose of reporting this. So OptimalJ supports the construction of PIMs and J2EE PSMs and the generation of executable Java code from these PSMs. CodaGen Architect, it supports UML class, state chart sequence, collaboration and use case diagrams, and code generation from your UML models to Java, C++, and etc. And Sauce, it uses a UML-like notation to define class diagrams from which code in Visual Basic or Java can be generated automatically. So these are the 3 MDA tools that I don't think it's active anymore. But I tried to find one tool, and I can see that there's this one tool called Sparks Enterprise Architect Tool. So this is basically yeah, I think you can see it on the description how it works. And I can see that there's some screenshots there that there's a lot of diagrams, UML diagrams, and you probably can do your MDA implementation here. So yeah, I guess that's it for me. Thank you for listening. Sir? Sir, I'm done na po, sir.
Okay, sir. Thank you very much. Okay. So again, I just want to reiterate, that this discussion, of course, when it comes to a model in MDE terms, is a representation of the part of. Can you hear me? No. Okay. Again. A model in MDE terms is a representation of a part of the functions, structure or behavior or system. So a model must be informal representation, annotation with a well-defined syntax and semantics. So the subset of UML that we have been used satisfies this requirement, and all MDA models that we consider in, of course, express in UML, but other formal language could be used instead in principle. Okay, so I think that's it for Sir Paulo discussion. May I request everybody to turn on your camera for the picture taking for our attendance for today. Para ko konti tayo ngayon na. So next meeting na lang yung magi-speaker lang ako ng ngayon. Meron lang ako assign na okay, so 1, 2, 3. Okay, thank you very much. Okay, thank you for attending our class at magandang umaga. Thank you, sir, Sir IC, napaka naman discussion na Sir IC, napaka clear at saka comprehensive. Okay, maraming salamat po ulit at magandang umaga. Stay safe, everyone.
Bye-bye.
Thank you, sir.
Ingat po kayo.